Yo-ho, welcome to the lab. Um, so, in the last video, we implemented a very trivial type for error propagation, but just the basics, nothing fancy. We probably have to do something to not always unwrap our ether, but let's deal with it once the problem arises. And in this video, I wanted to implement a very basic list type. And basically we have this. We can start implementing the scanner generator library, which is actually the focus video series. But yeah, since I want to explore how to do things in C++, to learn from my mistakes, we had to start from scratch. And so this time, let's build a list, I suppose. So perfect start. My mouse lags. Okay, perfect. Works. It works again. So let's create a new class. I think a header only, since it will be templatized. A new file called list, and it will be templatized by a type name. Call it T, and let's put it into the core namespace for our common classes, and using for list. Okay. Let's add it to our CMake. Or can I somehow sort those? To do this. I don't care. It's fine. It's fine. So let's include our list type. Of course, we're not using it, but it finds the class. It is basically a good start. So my list type won't be a linked list or something like this. I strongly hate the naming for the vector type in C++. It's called vector, but it actually means a list. I don't care how it is implemented. The concept is a list, which is allocated on one block, not a linked list or something like this. So I think the name of C++ leaks implementation details, which I don't like. But well, I have no strong feeling. So yeah, I said I hate it, but actually I don't have any strong feelings. I think it's not quite fitting, but yeah. So I would call it list, since it is shorter and the concept is clear. And if I have a specialized list, for example, which is linked or something, I will call it linked list or doubly linked list or something like this. But this list is just called list. So what do I want to do with my list? I want to create a new one, and I want to allocate things. So let's sketch out how I would like to use my list. I would like, for example, let's look. Well, we could put. So this was my muscle memory. I'm a C++ developer professionally, and well, we use Qt, so muscle memory kicked in there. So I would like to have for example, an empty constructor. Is this possible? Yeah. So I didn't specify one. So this would be fine. So let's allocate some data. Null pointer. Let's also keep track of the list's length and the capacity. I think so. It should be dynamic. It should grow. My list. So let's also keep track of the size and the capacity. So size is the So basically the size is how many elements are there in the list. And the capacity is how much space was already allocated. Capacity. So, and also it would be quite cool to have inline capacity, but for small lists that it doesn't need to allocate a thing, but let's just keep it very simple, a very simple concept. Everything else we can build later. So let's build a few accessors. So I would like to return the size, expose the size field, and also I would like to have the convenience is empty. And this one just checks if there are 0 elements. Also, I would like to have a non-empty, since I think it reads a little bit better than having to not is empty. So let's define all those methods as no discard. Okay, nice, perfect. So now I would like to, let's allocate memory when we call the constructor of list for now. I later plan to do inline. Maybe I can leave it as a to-do. Allow inline storage. Yeah, okay, let's just leave it in, but just the concept, the simple concept to start with. So now I would like to, so let's actually allocate some memory. I would like to have a constructor and a destructor begin with, just to plan it out. So, and then let's give our constructor a default, capacity. Let's allocate, I don't know, 4 elements. Okay. So how did I do this in I implemented everything in line. So I don't like this, I don't love this. I think I will refactor this later, but let's just start with our list. So I would like to implement it below so that our API is a little bit cleaner top here. So like this. So then I would like to do something like this. I would like to let's just call a helper function, which is called ensure capacity, and let's just pass it the capacity. This method doesn't exist, but it will, and I will also do this public. So it accepts a new capacity, and we'll implement it. Yeah, let's just implement it here. So this actually, I changed my mind. The constructor is simple enough that I can move it back here. So ensure capacity. Now, let's say if our capacity is less than new capacity, then we have to allocate something. So let's fail fast. If we already reached this capacity, we don't need to do anything. So in this case, I have to reallocate memory. So let's do this. Let's just use realloc. So like this, I suppose. So this is the capacity. So I have to calculate the new size in bytes. Now I can like this, as I think. Is it all? Is that all? So in here I can just say if we have data, free data. So and then it is also very easy, and I'm moving it. But it breaks. Let's keep it out of line. So it. Okay, of course it works. I have to cast it to T, I suppose, because this returns a void star. Doesn't it automatically cast? So let's say data. Let's say assert data. And then let's cast it. And I static cast it. No, I think not. Separate cast. So I didn't. So realloc. Where are you from? stdlib. So let's include everything I need. Include stdlib, and let's also include cassert. Okay, fine. I think now if I run this, I should get memory. I have a list. Size is 0, the capacity is 0, and it returned bad food, bad food. Perfect, I guess. But I got our capacity. So of course I have to store the new capacity. That is schon mal German word sneaked in. That is for sure. So let's redebug what happens. So now it seems like we get some memory. Wrong place. So we have memory, but this memory is of course uninitialized. Yeah, okay, perfect. So the size is 0, the capacity is 4. I think it worked. So nice. Nice. Works like a charm. How do I cancel the debug? Control F2. No, I won't learn this shortcut. Probably. Okay, sure. So now we can have a list, and it allocates 4 elements, and I think let's see. So this ensures our capacity. So if I plan, so realloc. So this should work. So but what? So but now if I, for example, plan to add 5 million elements, are those 5 million? Yeah. I can say as a consumer I could also use say ensure capacity, and then it should reallocate enough memory to hold this. Yeah. So let's put some data in. So let's define a method, call it add append. So I'm not gonna name it pushback. Add or append, I think will be it. So let's so let's overload it. for moving a value into this list and just copying it into it. So let's generate the method stubs for it. So now what do I want to do? I would like to ensure capacity for size +1 elements. So this will be a no-op. If we already have enough space, we will just allocate enough. So it will allocate one element more. Okay, I see. That's not what I want. So let's find enough space. So let's say so was mache ich? Do we do now? So, but let's just come back to it. I think it's called quadratic probing. Double check. I'm trying to learn something here. So what is this? No. This is for hash. So that is invalid. Invalid term, not the correct thing. But I'm trying to I grow not only one. So just as a reminder, I'm coming back to this. So now we have enough space to store one more element. And now I think I can do something like this. So the size, now, since this, if we don't have enough space to add one more element, this will grow the list and reallocate. Now size should be the index for the next possible. So it points to the next element in the list. The old size is the index of the new element we are currently adding. And then I can just copy construct it in place, I think. So just t value. And then, of course, I have to grow our size. I think that should be it. And I think I will do it very similar when you move a value in. Cd move value. So what is missing? I think utility. Oh, derp. So the new capacity. The new capacity. How do I want to do this? Let's just multiply it by 2, I suppose. But I would like to prefer to be at power of 2. So let's don't make this. Let's not let the user choose this. So the initial capacity is always, but if you know exactly how many elements your list will hold, will be faster. So I don't care. Let's keep it simple. So I will allocate enough space for 4 elements, and then if I so I see. So let's copy the capacity. Let's keep the old one, and while the capacity is less than the new capacity, so it is less the first iteration, but then I will multiply it by 2. And then the capacity remains, is a multiple of is a power of the initial capacity. So I like it. Let's keep it. So then I can also initial capacity. Also a better name, I guess. So then you still are able to specify it, but it keeps. Is it a power? No, it's a multiple. Yeah, it is a multiple. And it keeps a multiple, and I like it a lot. So let's see if it works. Okay, if I now allocate a list, it still should work exactly as before. No? I see, since it doesn't terminate. Since my old capacity is 0. I see. So let's hack it. Capacity is 0, and capacity is 1. Let's just and now I should be able to just, yeah. So I think it worked as before. Now my capacity is 4. And of course, this memory is not initialized, or it points to a wrong thing. Wrong. So, but this is fine. So now I'm should be able to add. Let's add some strings. Let's add. Let's add a couple of strings. So why? Did I do wrong? I think yeah. It wants a pointer. And now the program is still running. Okay, now it should have a size of 3 and capacity of 4, so we have still remaining space for one more element. And if I now look into the data array, it contains a valid string view. Cool. So now I can put values in. Now if I put one more value into the list, this should work as intended. So now our initially allocated memory should be filled up. But if I add one more element, it should reallocate. So let's see if our capacity grows. So why is our capacity 5? This should not be valid. Unexpected. So I allocate capacity elements, but I set new capacity. I see, I have to set capacity. Now I think now it will work. Okay, fine. So now it is a multiple of our initial capacity, which is implicitly set to 4. Yeah, I like it. Okay. So let's build an accessor function. allows me to look at my element. So let's introduce operator, the index operator. For const and non-const access. Let's implement those. So ID doesn't want to implement this method, so I have to do it myself. Of course, here you go. Thanks. So, and then I also will produce a method I will call, put it here. I will call it inbounds. It takes an index. It will decide if the index is less than the size, just as a convenience. No, I don't need to put it here. And we know discard. So why? Let's just ignore it. The warning will go away. So in here I can then bounds assert that my index, a given index, is in bounds. Try out. Try index 9. Oh, 9. German again. The German word. This index out of bounds. So then I can just access data with the index. Read from this place. I just copy and paste it and paste it here. And here the index didn't name the parameter. Oh no, doesn't link. My debugger still accesses the file. So that is the beauty of Windows. You can't write a file when it's currently executed. I hate it. So now let's iterate through our list. List.size plus I list I debug log. Let's print list I as a string, followed by the element, followed by a line break. So oh, I think I don't have to do this. I see, I would have to do this if I would have a pointer, done the pointer arithmetic myself. So I don't know why this gets underlined. So now it works. So perfect. Oh, of course, I'm an idiot. I am an idiot, and I would wanted to print text like this. So what is the problem? So I've ran into the problem before, but let's just print fix error. So now it looks like it works. So let's for now accept it. So this should be our list, our basic list. Of course, I don't have a for each method. You can't for each over my list. I will add it immediately. But I think I will go to my logging again and reduce overloads, print every kind of integer and loads maybe. So let's start with this. So because I only know how to log ins for now, but I'm really want to log every integer type which I alias myself in this file. So, and since those are just aliases for U64, I don't want to add it, but it's specialized printer for them. But of course, want to add printers for all the basic types. So let's start a logger for a let's just add them all. Let's start with signed first. Signed. This will a little bit will be very copy paste, but will pay off in the future. Since I didn't want to do it previously, but I think I will just do it now, since it will be convenient if they are already in place. So, and then let's just copy them all. Maybe I will move them into another file later. So let's see. Can I just replace S by this regex? Okay, regex mode. Can I replace S followed by a digit? Okay, yeah, sure. By U followed by the digit. How do I refer to the group? This return the how can I refer to the group? Okay, classes, I don't care. How can I don't need to match greedy. But how can I capture, I think? Capturing group. /n. So in the groups, are they referred to by starting by 1 or by 0? Can't remember. Now, will this work? Oh, you 1. Oh, don't want to replace it by 0, u0, but by I have to again. So how can X as a capturing group? Whatever the nth capturing group matched. Okay, but this is the capturing group, so it matches, but we replace. So of course it would have been a lot faster if I'd done it by hand, but so was it backslash or forward slash? I already forgot. But this backslash n \n. I've done that. Or do I have to say literally n? No? No, can't be. So let's just try it. No, it doesn't work, so I'm doing it myself. So that was interesting. So I could have done it in Emacs. I know how it works there. So now I have to implement a few loggers. But I think I will copy paste it here too. So let's start. Let's copy it 2 times for the signed. So 16, 30, 64. Let's repeat the same types here. So I know how to do this in the line. So multiple cursor. So let's just add every case. So here it is simple since the letters are all aligned. So I'm expecting a warning. Don't get a warning. So because I don't know if I use the correct format string. Or I don't. Especially for 64-bit integers. So let's just Google it up. There is a macro for printf macro for 64-bit integers. So let's just use it. Macro, which is called like this. It is from int types. So I just go there. How's it called? P-R-E-R-I. Oh, where did I include int types? Oh, let's jump there and just P-R-E, look. So it doesn't defined here. It is defined here. So define, I don't have to look here, but I think I should have, should be in scope since I'm importing types here, and types includes types, std int. So now let's see, pri. Okay. Types. I didn't include this. So let's go to it is twisting also always included in my type struct. So now I have them all. Perfect. So what is, let's see, what is this? What is I? So was okay. Let's use let's use them. And also, where's unsigned? Unsigned here. They're just U, and in this case, D. Okay, perfect. Let's just use them then. So then what did you say? D8. Yeah. 16. Oh, it could be a little bit more smart here, but do it with those. So let's multiple cursor it. So I can just say PRIU, and I think I can just paste it. Yeah, so that should be it. So for the signed and unsigned, and that's also we are edit. Let's also add specializations for floats, for float and for double, while we are at it, of course. My future self will thankful for this. back and float and double, float, double. And there's also, I think there's also for doubles here. Double, float. So D is, sorry. Let's use I think it is, so I think the macro same, but I like it a little bit better since D is also knows how to print decimals. I think the D stands for decimal, so let's use D here for printing floats and D for I. So I think let's double check. Print F float and double. Okay. F is for float. So decimal. I was wrong. Okay, cool. Nice. Let's. So I'm an idiot basically. So the code is called int types. So let's use D. Since the format specifier is called D, and here I'm using just %. What happened? So I switched the keyboard layout with a shortcut. Let's just keep this format. Let's say 32. And this is of course F. And let's also just that we keep similar names. I think it, well, just to be consistent with the integer print. So I think now we should have enough logging capabilities for now. Let's commit it as a separate thing. So I just, what did I add? Just the logging for everything. Log every int floats. Introduce where shall I? Logger for all int and float types. Okay, so logging. Now I should be able to just print the I. Okay, it already builds. Perfect. So, and now if I run it, it should still work, of course. Okay. But LLU. So, didn't expect this to happen. So, something went wrong with my logger visualization. So, I'm LLU. Oh, I see. I see what my mistake. I see my mistake. So I basically, this is just the specifier. I have to prefix it by a %. So let's something like this. And of course, I now have to kill it. This line. I just spawned a couple of the cursors. Okay, now it works, so perfect. So let's just amend it. So I should have tested it before, but yeah, since this is the last commit, doesn't matter. Okay, so this is that is list code. Okay, so let's jump back to our list. So now I would like to introduce the possibility to iterate over my list. Let's say like this. Of course, there's no I anymore, so let's cheese it by saying city like this, but I want that this works. So it doesn't have a begin function, of course. So how can you achieve this? I've never implemented iterator for C++. So first, let's just commit the list as is. Implement a basic now let's just stick with the other style. Introduce class list. Okay, so now how do I do the iteration? C++ iterators. So yes, this is a plus. No, this is a plus. So how do I do this? Well, this is ugly. So this is German. I don't like this. Why do I don't want to do this? I don't want to dummy position. Do I have to introduce a new class now? Hate it. Thanks, I hate it, C++. I think that's all what we have to do. So let's go. So how do I want to do this? Do I want to keep a reference to this in the index? Or do I want to do this as a style of C++? Oh, but I could do it something like this. Then of course I had to implement the list iterator class. So I think it just has to support a couple of operators. So let's see. Plus iterators. Let's steal something from the internet. Yeah, so I could do all categories since my object could theoretically be an iterator in all directions. It could also be random access. But I don't want to implement all this nonsense. Can't I just say C++ thing? Since everything, my whole memory region is, or isn't there a thing I can use? Just an std iterator. Since I don't really want to implement anything, can't I just give it a input iterator? So I have to decide which. Okay. I see. What is this? So a forward iterator. Of course, it is an input iterator, I think. So I like the pretty picture from before. This, where is the picture? Was it this? Yeah. Okay, this table. I want a input, maybe an input and an output operator. So I have to support equality. So I think. So I don't want to support this. This is stupid. Decremented, yeah, I don't care. So basically, I'm an input. I want to just an input iterator just to begin with. Output iterator would be also great. But for now, let's just stick with input iterator. So our list, let's just see if I can just use a std iterator. How do you do this? So value difference, pointer reference. So, and then, so do I still have to implement this crap myself? So maybe no iterators then. I mean, I could also inherit from std. No? So ugly. Don't want to do this. But I would really like to be able to use for each loops. It is so ugly. So let's just So let's just keep a pointer. Also a pointer to the end. And I think I can just do I have to keep both bounds? No, just the. Okay, let's just experiment. So let's just say, okay, begin returns a list iterator of element type, and I return give it a pointer. So let's see if I have two iterators. I think I just have to. Yeah. Okay. I just need to have one pointer. So let's call it element. The list, of course, I want this to be private, and the list iterator just accepts the pointer to the member. It just finds it. Okay. So of course I want to be explicit in this constructor. So now I could. So the begin, of course, is just end data, and end would be end data plus size. So, and since pointers are typed the element type, I can just do a simple pointer arithmetic. So also so what's begin and end begins? So I don't know. So okay, now I have the methods begin and end. Now I have to support comparisons of my iterator. So basically, let's look at the picture again. So the table, I mean. So I have to support those things, those operations. So let's just start working on it. So operator, let's just begin with the basic one. So let's accept another operator. Let's compare two operators by just comparing the element pointers. So if this element is the same as the element pointer of the other thing, then they are considered equal. Why do you cry? So, and I think we can just reuse this method to. Here we are reusing the equals operator to implement not equal. So yeah, okay. Now it stopped crying. So now we support equality. What do we need? So operator star. So operator star. Let's support operator star. I think it has to return a reference. So what operator star do I have to think? Yeah, well, let's just overload it to be sure. So let's turn element. No. So we just return. No, we return dereference it, of course. Okay, sorry. So I think fine. What are we missing? The plus plus. So, but why do I have to? Okay, I have to dereference an L value for mutable iterators. I don't have a mutable iterator, I think. No, I don't have one. I just want to support input operator for now, and I have to implement plus plus. Okay, what do you want? Operator plus plus. So, but how do I can differentiate between the pre-increment and the post-increment? How I have to write this? Okay. Works like this. So operator plus plus. So why does this accept an integer as a second element? I have this. I implement this. So, but why are there two different things? So, I see. One returns a copy of the iterator, but this uses a pre-increment thing. See, it copies itself, pre-increment, and returns the new value. So this is the yoink it. So the iterator type so it mutates itself. I see. So this is why it returns a reference to itself. I think it just increments the pointer. The post increment just copies it, increments it, and returns it. Okay, that's great, but I don't get why you have to specify an integer. So this is not really nice. It would be better if you could write something like this. Plus plus operator, since the pre comes first. You can just call this post increment. But, well, I didn't make the rules. So and I won't call it redval, I'll call it iterate. Yeah. So now non-constant object. Why does it return a non-constant object? This problem. This one doesn't change. So I don't get what the IDE wants here, so I'm just going to ignore it for now. But now, for loop, and my for each loop compiles. So that was a struggle. For each loops are really horrible in C++. So if you introduce your own collection type, so my beautiful list got an abomination, allows it to be iterable. Let's just hide it and never look at it again. So, but it seems to work. Basically, I'm happy. So we have a list. Yeah, so that's actually everything I wanted to achieve. So I struggled through the iterator thing since I've never done it. And you are the witness that, well, it would have been easier, C++. But yeah, okay, sure, it works. And it probably supports a lot of corner cases, which you often don't really need. But I think it could be the most general solution, since it also supports like the input and output iterators, where you can do a lot of interesting computation with very short amount of lines you actually have to write. So might be the most general solution to support everything, but then, well, look at what your iterator has to support. This will be a pain. Okay. So, but now we did lists. So I think I said I wanted to talk about allocations next video, but yeah, let's see what we're actually going to do. So I think I just don't want to overcomplicate things and just allocate everything on the heap. Don't do anything fancy like allocators or something like this yet. Maybe later. So let's for now just allocate everything. So let's skip this actually. I said I want to talk about it, but let's just skip it. Let's just start working on the real implementation and look. Yeah, let's just see what we actually need. The next video. So just as a sneak peek, next video we are going to actually implement a scanner generator library. So, but first things first, wrap up this video. I achieved everything I wanted to achieve. Implemented a list, a very basic list, probably contains errors, but yeah, it's my list and I'm proud of it. Very simple, of course. It doesn't have a way to initially construct some elements into it, but it will be fine. It will be fine. I can always grow and extend its functionality, but for now, everything I need, it supports. So next time we're going to work on the actual code. Yeah, so I'm repeating myself. I'm sorry. Thanks for watching. See you next time, hopefully. Bye.